Hey, sleepers! Tonight, we're venturing into a forgotten laboratory of the mind, a place where strange forces were witnessed and a secret science was born. Imagine a darkened room in the heart of the roaring 20s. The air is still, thick with the scent of ozone and warm vacuum tubes. On a wooden workbench, a small, curious device made of metal and wax begins to hum with an unseen power. It levitates just for a moment, straining against a delicate thread, held aloft by a force that seems to defy the very laws of the world. This wasn't a magic trick. It was the beginning of a strange and winding journey into a phenomenon that promised the world, but held a very different secret. So before you get comfortable, take a moment to like the video and subscribe. It helps our little corner of the cosmos grow and ensures you won't miss our next journey into the quiet and the curious. And while you're there, we love to know where you're listening from. Please share your city or country and the local time in the comments below. It's wonderful to imagine our voices reaching you, creating a shared moment of peace all across the globe. So close your eyes, take a deep breath, and get ready to drift off as we explore the strange, silent hum of a forgotten dream. Our story begins not in a grand state-sponsored facility, but in the mind of a young man with a restless and boundless curiosity. His name was Thomas Townsend Brown. He was born in 1905 in the quiet town of Zanesville, Ohio. The world he entered was one of staggering transformation, a place where the certainties of the past were being dismantled day by day. Think of the air in 1905. The first flight by the Wright brothers had happened just 2 years earlier, a sputtering 12-second hop that nonetheless proved humanity was no longer tethered to the ground. Invisible radio waves, a concept that would have been pure sorcery just a generation before, were beginning to crackle with messages sent across vast oceans. It was an era intoxicated with possibility. The rules of what could and could not be done were being rewritten, and the line between science and science fiction was a wonderfully hazy, inviting frontier. From his earliest years, Thomas, or T. Townsend Brown as he would later style himself, was captivated by the unseen forces that govern our world. While other children were concerned with games of stickball and marbles, he was building. He was a born tinkerer, a basement inventor. His family, being well-to-do, nurtured this passion. They provided him with the resources to construct his own laboratory, a personal kingdom of wires, batteries, bubbling chemical beakers, and the beautiful, glowing glass bulbs of early electronic equipment. He was drawn, almost magnetically, to two of the universe's great fundamental forces, electricity and gravity. Electricity was the new god of the age. It was tangible, controllable. You could see it arc between 2 points in a brilliant spark. You could feel its power turn a motor. You could watch it bring light to a darkened room with the flick of a switch. It was dynamic, powerful, and thrillingly dangerous. Gravity, by contrast, was the old, silent, immutable god. It was everywhere and nowhere. It was the steady, invisible hand that held the moon in its orbit, that pulled the tides across the shore, and that kept your own 2 feet planted firmly on the floor. It was a profound mystery, a force so woven into the fabric of existence that to question it was like questioning the reality of time itself. For the young Brown, these 2 forces were not separate entities. They were cosmic siblings, 2 sides of the same fundamental truth. He possessed a powerful intuition, a deep and unshakable conviction that they had to be connected. He couldn't prove it with the mathematics of the day, but the idea lodged itself in his mind, becoming the guiding star of his entire life's work. His first tangible clue, the first whisper of evidence that he was on the right track, came from a marvel of modern technology called a Coolidge tube. Now, a Coolidge tube sounds like something from a futuristic tale, but it was, in essence, a highly advanced type of X-ray tube invented just a few years earlier by William Coolidge. Imagine a very special kind of light bulb, one made of thick glass and intricate metal components. When you feed it an enormous amount of electricity, it doesn't produce visible light. Instead, it emits a stream of X-rays, those mysterious invisible rays that could pass through skin and muscle to reveal the stark, beautiful architecture of the bones within. It was a tool of miracles for medicine, but to function, it required an extremely high voltage, a powerful electrical potential that hummed with contained energy. Young Brown, in his home laboratory, was experimenting with one of these tubes. He had it resting on a very sensitive laboratory scale, an instrument designed to measure tiny changes in weight with great precision. With everything perfectly balanced, he threw the switch. The tube came to life, a faint glow emanating from its core, and it began its invisible work of generating X-rays. But Brown's sharp eyes noticed something else, something utterly unexpected. The needle on the scale quivered and moved. It registered a tiny, almost imperceptible loss of weight. When he switched the tube off, the needle swung back to its original position. The weight returned to normal. He tried it again. He turned the power on, and the effect was there, a consistent, repeatable anomaly. He turned it off, and it vanished. For most people, this would have been a curiosity, perhaps an error in the equipment, a vibration from the power source, or some strange effect of the air heating up. But for T. Townsend Brown, this was a moment of profound revelation. It was the thunderclap of discovery he had been waiting for. In his mind, he was not seeing an experimental error. He was witnessing a direct, physical interaction between the intense electrical field within the tube and the all-encompassing gravitational field of the Earth itself. He believed, with every fiber of his being, that the electricity was somehow pushing against gravity, creating a small shield or a counterforce. This was a profoundly radical idea, bordering on scientific heresy. The physics of the time, even the mind-bending new theories of Albert Einstein, treated gravity and electromagnetism as fundamentally separate forces, each operating according to its own distinct set of rules. But Brown was now convinced he had found a hidden bridge between these two great domains of nature. He had found a locked door, and in the strange behavior of the Coolidge tube, he believed he had just been handed the key. This discovery fueled his ambition. He went on to study physics in college, first attending the prestigious California Institute of Technology, better known as Caltech, and later transferring to Denison University in Granville, Ohio. It was at Denison that he found a kindred spirit, a mentor who would not dismiss his wild ideas, but would instead help him explore them. This was Professor Paul Alfred Biefeld. Biefeld was a respected professor of physics and astronomy, a man who had studied in Europe and carried an air of quiet intellectual authority. He saw in the passionate, sometimes eccentric young Brown a flicker of unconventional genius. He was intrigued by Brown's persistent stories about the Coolidge tube. Where others saw error, Biefeld saw a question worth asking. He listened. Together, in the hushed, scholarly quiet of the Denison University Physics Laboratory, they set out to investigate the phenomenon in a more rigorous and controlled way. They decided to simplify. The Coolidge tube was a complex piece of equipment, with many things happening at once. To truly isolate the effect, they needed something far more basic. They turned their attention to the capacitor. A capacitor is one of the most fundamental building blocks of electronics. If you've ever taken apart an old radio or a piece of modern technology, you have seen dozens of them, little cylinders or ceramic discs soldered to the circuit board. The concept behind them is beautifully simple. Imagine you are making a sandwich. You have 2 slices of bread, and between them, a layer of cheese or lettuce. The bread represents 2 conductive plates, usually made of metal. The filling in the middle represents an insulating material, something that doesn't allow electricity to flow through it easily. This is called a dielectric. When you connect this electrical sandwich to a battery, a positive electrical charge builds up on one plate, and a negative charge builds up on the other, but the charges cannot cross the gap because of the insulator. The capacitor becomes a small, temporary storage tank for electrical energy. Brown and Biefeld began to construct their own unique capacitors. They weren't the simple, symmetrical sandwiches you find in a radio. They designed them to be deliberately asymmetrical. One of the conductive plates would be very small, often just a thin wire or the sharp edge of a metal foil. The other plate would be much, much larger, perhaps a broad sheet of metal foil. The shape was crucial. It might be a triangle or a fan or a disc with a wire suspended above it. Then, they would charge these asymmetrical capacitors with extremely high voltages of direct current. We're not talking about the 120 volts from a wall socket. We are talking about tens of thousands, sometimes hundreds of thousands of volts. And when they did this, when they poured that immense electrical pressure into their strange devices, something truly remarkable happened. The capacitor would move. It would produce a tangible, measurable force. It would lurch or glide in a specific, predictable direction. It always, without fail, moved toward its smaller, positively charged plate. This was it. This was the phenomenon, distilled to its purest form. This was what would forever be known as the Biefeld-Brown effect. For Brown, this was the ultimate vindication. This was the irrefutable proof he had been searching for. He had created a simple device that, when fed with electricity, produced a propulsive force without any of the usual trappings of motion. There were no propellers chopping at the air, no wheels turning on the ground, no hot gases blasting from a rocket nozzle. It was silent, solid-state propulsion. He believed he had engineered a direct conversion of an electrical field into a gravitational one. He was on the brink of creating a new technology, one that could silently lift ships into the heavens with nothing more than a powerful hum. It was the age-old dream of anti-gravity, and in that quiet Ohio laboratory in the 1920s, a young Thomas Townsend Brown was certain that he held its secret in his hands. Let's just pause for a moment and visualize that scene. The low, warm light of the lab, casting long shadows from the strange contraptions on the workbench. The distinct, sharp smell of ozone, a byproduct of high-voltage electricity ionizing the air. A young, brilliant student and his seasoned professor leaning in, their faces illuminated by the faint glow of vacuum tubes, watching a simple construction of wire and foil seemed to defy the most fundamental law of the universe. It must have felt like they were standing on the precipice of a new reality, a new physics. The thrill, the sense of holding a secret that could change the world, must have been utterly intoxicating. This was more than just an experiment. It was, to them, a glimpse behind the curtain of reality. And like many such glimpses, its true nature was far more complex and far more connected to the world we already know than its discoverers could have ever comprehended. The silent hum was real. The mysterious force was real. But its origin was not in the distortion of space-time, but in the invisible, swirling dance of the very air in the room. So now, let us take a gentle breath and allow our focus to drift from Brown's hopeful, revolutionary interpretation to the clear, elegant explanation provided by modern physics. It's a journey from a dream of anti-gravity to the fascinating reality of a different kind of force. The effect Brown and Biefeld observed was absolutely real. Their devices did move, but the reason, as we now understand it through a century of further research, has nothing to do with manipulating gravity. It is a beautiful, subtle process that belongs to a field of study called electrohydrodynamics. That name, electrohydrodynamics, sounds immensely complicated, but if we break it apart, it becomes quite simple. Electro obviously refers to electricity. Hydro is a Greek root that means water, but in physics, it's used more broadly to refer to any fluid, and the air that surrounds us is a fluid. And dynamics is simply the study of movement. So, electrohydrodynamics is the science of how electrical forces can cause fluids, like air, to move. The common, and much more descriptive, name for the force that propels Brown's devices is ionic wind. And that name is a perfect, literal description of what is happening. It is a genuine wind, a directed flow of air, created by electrically charged molecules called ions. To understand this, let's imagine the air in the room around you right now. It's a vast, invisible ocean composed of countless tiny molecules, mostly nitrogen and oxygen. In their normal state, these molecules are electrically neutral. They have an equal number of positive protons in their nucleus and negative electrons orbiting that nucleus. Think of them as a huge, calm, and indifferent crowd of people filling a vast public square. They are just milling about, bumping into each other gently, with no overall direction or charge. Now, let's introduce Brown's asymmetrical capacitor into this placid scene. Remember, it has two key parts: a very small, sharp electrode, like a thin wire, and a much larger, smoother electrode, like a flat plate. Let's say we connect the small, sharp wire to the positive terminal of a very high voltage power supply, and the large plate to the negative terminal. When we flip the switch, an incredibly intense electric field forms in the space between the two electrodes. This field is strongest right around the sharp point of the wire. A sharp point concentrates an electric field, just as the tip of a needle concentrates pressure. This intense field is like a powerful disruptive force, suddenly appearing in our calm public square. It's so strong that it begins to tear the air molecules apart in the immediate vicinity of the wire. It physically rips the outermost, loosely held electrons away from the neutral nitrogen and oxygen molecules. When a neutral molecule loses a negatively charged electron, its balance is upset. It now has more protons than electrons, giving it a net positive charge. It has become a positive ion. In our analogy of the public square, a small number of people standing right next to the disruptive force have suddenly had their wallets, electrons, stolen. They are no longer neutral observers. They are now positively charged and very agitated. This process of creating ions is called ionization, and the faint violet or blue glow that often appears around the sharp electrode, known as a corona discharge, is the visible light given off by this energetic process. It's the visual evidence of the air itself being electrified. So we now have a dense cloud of newly created positive ions right next to our small positive wire. But what do positive charges do when they are near other positive charges? They repel each other. They push each other away. And what do they do when they are near a large negative charge, like our big metal plate on the other side? They are powerfully attracted to it. So these new positive ions are immediately and forcefully pushed away from the wire and begin to accelerate at high speed across the gap toward the large negative plate. They form a directed stream, a current of ions flowing through the air. But this stream of ions doesn't travel through empty space. It has to push its way through the vast, dense crowd of neutral air molecules that are still just hanging around. As our fast-moving positive ions race towards the negative plate, they constantly collide with these much more numerous neutral molecules. It's like a few panicked people trying to sprint through a thick stationary crowd. They bump into people, they shove them, they transfer their momentum. Each individual collision is a minuscule event, a tiny push. But there are billions upon billions of these collisions happening every single microsecond. The cumulative effect of all these tiny pushes is enormous. The directed stream of ions creates a cascading stampede in the neutral air. It drags the neutral air along with it, creating a powerful directed flow. It creates a wind. This is the ionic wind. It is a silent, invisible jet of air, generated without any fan blades, flowing from the small electrode to the large one. Now, we bring in one of the most fundamental laws of all physics, Sir Isaac Newton's third law of motion. For every action, there is an equal and opposite reaction. The action here is the capacitor device pushing the air molecules, both the ions and the neutrals they collide with, away from it, creating the wind. The reaction is those air molecules pushing back on the capacitor device with an equal and opposite force. It's the exact same principle as a rocket engine, which pushes hot gas out the back, the action, to propel the rocket forward, the reaction. In this case, the device is pushing a column of air, and that column of air is pushing the device. And so, the entire apparatus moves, pushed forward in the direction of its small positive electrode. This explanation, based on well-established physics, is so powerful because it accounts for every single detail Brown observed. It explains why the asymmetry of the electrodes was absolutely critical. It explains the faint hissing sound, which is the sound of the corona discharge and the moving air. It explains the faint smell of ozone, because the high-energy ionization process can split normal oxygen molecules, O2, which then sometimes reform into ozone, O3. And most importantly, it offers a definitive, testable prediction. This prediction forms the basis of the most crucial experiment to differentiate between Brown's antigravity theory and the ionic wind theory. The question is simple. If this entire effect is based on the device pushing on the surrounding air, what would happen if there were no air to push on? What would happen if you placed the device inside a vacuum chamber and pumped all the air out? If T. Townsend Brown was correct, if the force was a true interaction with the gravitational field, then removing the air should actually make the effect stronger. Without the friction and resistance of air, the device should move more freely, its electrogravitic force acting unimpeded. But if the ionic wind theory is correct, the effect should vanish completely. Without air molecules to ionize and push, there can be no wind, and therefore no reaction force. And that is precisely what happens. When modern researchers place a Biefeld-Brown-style lifter inside a vacuum chamber and turn on the power, it remains perfectly still. It sits there, silent and motionless, no matter how many thousands of volts are applied. As the air is slowly let back into the chamber, the force gradually reappears. This is the conclusive, unambiguous evidence that proves the Biefeld-Brown effect is not anti-gravity. It is a brilliant and captivating demonstration of electrohydrodynamics. It is so important not to view this as a simple debunking or a failure on Brown's part. He was a pioneer. He stumbled upon a genuinely fascinating and non-obvious physical phenomenon. His interpretation of its cause was incorrect, deeply colored by his lifelong dream of linking electricity and gravity. He suffered from what psychologists call confirmation bias. He was so certain of the answer he was looking for that he interpreted all the evidence as pointing towards it, overlooking the simpler, more mundane explanation. But his meticulous work, his daring ideas, and his captivating demonstrations lit a spark. He opened a door, and even if he mistook the label on it, we can still be profoundly grateful for the strange and wonderful new room he revealed to the world. Now, let us allow our story to drift forward in time, leaving behind the academic curiosity of the 1920s and entering the tense, supercharged atmosphere of the 1950s. The world had been irrevocably altered. The Second World War had showcased the terrifying power of advanced technology, culminating in the atomic bomb. A new kind of global conflict had emerged from the ashes, the Cold War. The United States and the Soviet Union, former allies, were now locked in a high-stakes competition for technological, military, and ideological dominance. Each nation was desperately searching for a breakthrough, a secret weapon, a game-changing technology that would provide an insurmountable advantage. This was the era of the jet age, the dawn of the space race, and a time of pervasive paranoia about secret Soviet advancements. Simultaneously, a strange new phenomenon was capturing the public imagination. All across the United States and the world, people were looking to the skies and seeing things they could not explain. Reports poured in of strange lights, of silent, disc-shaped craft that could hover motionless and then accelerate to impossible speeds, making hairpin turns that would crush any human pilot. The famous sighting by pilot Kenneth Arnold in 1947 had coined the very term flying saucer. The alleged crash of such a craft near Roswell, New Mexico, that same year only added fuel to the fire. The idea of visitors from other worlds with their vastly superior technology was no longer just the stuff of pulp magazines. It felt like a real and pressing possibility. Into this heady mixture of military paranoia and public fascination with flying saucers stepped a middle-aged Thomas Townsend Brown. He was no longer the bright-eyed student from Ohio. He was a seasoned independent researcher, more convinced than ever of the reality of his discovery. And for the first time, he found a powerful audience that was not only willing to listen, but was actively looking for exactly what he was offering: the United States military. To the generals in the Air Force and the admirals in the Navy, Brown's claims sounded almost too good to be true. Here was a man claiming to have discovered a new form of propulsion, one that used powerful electric fields to manipulate gravity itself. He showed them his demonstrations: small, lightweight discs that would lift off a table and hover silently when powered up. The military brass looked at these silent, levitating discs, and then they looked at the newspaper headlines and the classified intelligence reports about flying saucers. The resemblance was uncanny. The reported characteristics of UFOs, silent flight, high speed, lack of exhaust, seemed to perfectly match the theoretical capabilities of Brown's electrogravitic drive. A cascade of urgent questions must have filled their minds. What if Brown had accidentally rediscovered the technology that powered these mysterious craft? Or, the most terrifying thought of all, what if the Soviets were already developing this technology? The mere possibility, however remote, was too significant to ignore. And so, in the early 1950s, Brown's research was elevated from a private obsession to a matter of national security. He was brought into the fold, working on classified projects for various branches of the armed forces. The most famous and ambitious of these was a 1952 proposal for the Navy, codenamed Project Winter Haven. This was Brown's magnum opus, his grand vision laid out for military planners. He proposed the development of a disc-shaped anti-gravity interceptor aircraft. The proposal documents, now declassified, read like science fiction. He described a saucer-shaped craft, perhaps 100 feet in diameter, powered by a massive electrogravitic drive. He claimed it would be capable of speeds exceeding Mach 3, 3 times the speed of sound, with the ability to take off and land vertically, hover silently, and outmaneuver any conventional jet. It was, on paper, the ultimate weapon, a technological leap so profound it would render all existing air forces obsolete overnight. The military was sufficiently intrigued to provide funding for further research and demonstrations. Imagine yourself as a high-ranking officer in that era, brought into a secure facility to witness a demonstration. You are a man accustomed to the thunderous roar of piston engines and the piercing scream of early jet turbines. You understand propulsion in terms of propellers and fuel and violent combustion. And then, this quiet, intense civilian scientist, T. Townsend Brown, ushers you into a room. On a table sits a collection of metal discs, perhaps 3 feet across, looking like futuristic hubcaps. They are connected by thin wires to a large, humming power generator in the corner. Brown offers a few words of explanation, then calmly flips a switch. The hum from the generator intensifies. A faint, violet glow appears around the edges of the discs, and the air fills with that sharp, clean smell of ozone. And then, with an eerie silence, the discs lift off the table. They rise into the air, spinning slowly, held aloft by a force you cannot see or comprehend. It would have looked like magic. It would have felt like the future had arrived. These demonstrations, often with what Brown called his lifters, were genuinely impressive. He had refined his designs, typically using a frame of lightweight balsa wood covered in aluminum foil. A very thin copper wire would be suspended a few inches above the main foil body of the craft. The thin wire served as the sharp, positive electrode, while the broad foil surface was the negative electrode. When tens of thousands of volts were applied, a powerful ionic wind was generated, flowing downwards from the wire to the foil. This downward rush of air created an upward thrust, lifting the feather-like craft. It was a masterful and visually stunning demonstration of electrokinetic propulsion. However, the military also employed teams of sober, methodical scientists and engineers. Their job was not to be dazzled, but to measure, calculate, and evaluate. They looked beyond the spectacle and began to analyze the hard data. They measured the electrical power consumption of the devices and meticulously measured the amount of thrust or lift that was produced. And the results they found were deeply, fundamentally disappointing. The thrust was incredibly weak. Yes, it was enough to levitate a model made of balsa wood and aluminum foil, which weighs next to nothing. But the force produced was minuscule compared to the power consumed. The all-important thrust-to-power ratio was, In the words of one official report, abysmally low. There was simply no conceivable way to scale this technology up. To lift a craft made of structural metal, carrying a pilot, fuel for a power source, and a payload would require a power plant of such monumental size and weight that the device could never hope to lift itself. It was a paradox. To get more lift, you needed more power, but more power meant a heavier generator, which in turn required even more lift. The math was a vicious circle that always led to failure. Furthermore, the military's own researchers conducted the definitive tests. They placed the devices in wind tunnels and vacuum chambers. They confirmed, just as academic physicists had, that the thrust diminished as air pressure was lowered and vanished entirely in a vacuum. Their conclusion, reached after several years of investigation, was clear, professional, and unequivocal. The Biefeld-Brown effect was a real phenomenon. It was caused by the movement of ionized air. It was not anti-gravity. And as a practical method for propelling an aircraft of any significant size, it was a technological dead end. By the late 1950s and early 1960s, official military interest had evaporated. The funding was cut, the classified projects were terminated, and the files were stamped concluded and put away in archives. Project Winter Haven remained a tantalizing what-if, a dream of silent saucers that never flew beyond the pages of a proposal. Brown's brief and secret career as a defense contractor was over, but the very secrecy that had surrounded this research created an enduring myth. The fact that the military had taken Brown's ideas seriously enough to classify them led many enthusiasts and conspiracy theorists to believe the opposite of what had actually happened. They believed the military had confirmed anti-gravity was real and had hidden the technology from the public for their own purposes. This narrative of suppressed free energy or alien technology has persisted for over half a century, fueled by the memory of those strange humming discs that once flew in a secret military lab. The truth, as revealed in the declassified documents, is a far more sober tale, a story of due diligence, of a hopeful dream being subjected to the rigorous, unblinking gaze of scientific and engineering reality, and ultimately being found wanting. So, as the military turned its full attention to building faster jets and more powerful rockets, where did that leave T. Townsend Brown in the eyes of the broader, non-military scientific community? While his work found a temporary, clandestine audience within the Pentagon, its reception in the open, global forum of academic, peer-reviewed science was, to put it mildly, frosty. The world of academic science operates on a fundamentally different basis than a military research program. The primary goal is not just to build a device that works, but to achieve a deep and verifiable understanding of why it works, and to ensure that this understanding is consistent with the vast, interconnected edifice of established scientific knowledge. Brown's central claim that he had discovered a direct link between electromagnetism and gravity was an extraordinary one. And within the culture of science, there is a powerful and essential principle, famously articulated by the astronomer Carl Sagan. Extraordinary claims require extraordinary evidence. Brown's evidence was his array of moving capacitors. But his theoretical explanation for why they moved was where he consistently faltered in the eyes of his scientific peers. He developed a conceptual framework he called electrogravitics, but he was never able to express it in the language of science. Rigorous, predictive mathematics. His theories were qualitative, descriptive, and ultimately incompatible with the known laws of physics. the dominant theory of gravity in the 20th century, and still today is Albert Einstein's general theory of relativity. This is not just a guess or a good idea. It is one of the most rigorously tested and spectacularly successful theories in the history of human thought. General relativity describes gravity not as a simple force pulling objects together, but as a consequence of the geometry of the universe itself. Imagine a flat, stretched rubber sheet. This represents the fabric of space-time. If you place a heavy bowling ball in the center, the sheet curves and dips. That curvature is gravity. A smaller marble rolling nearby will have its path deflected by that curve, causing it to orbit the bowling ball. Einstein showed that mass and energy tell space-time how to curve, and the curvature of space-time tells mass and energy how to move. Brown's idea of an electric field blocking or pushing against gravity simply doesn't make sense in this framework. It would be like trying to block the curve in the rubber sheet with a gust of wind. They are different kinds of phenomena. Brown's ideas were not an extension of Einstein's theory. They were a contradiction of it, and he offered no coherent mathematical replacement. As a result, his theoretical papers were never accepted for publication in any major, reputable, peer-reviewed scientific journal. The peer review process is the cornerstone of modern science. When a scientist has a new result or a new theory, they write it up and submit it to a journal. The journal's editor then sends the paper to several other anonymous experts in the same field. These experts, the peers, review the paper for errors, flawed logic, and unsupported claims. It's a rigorous, often harsh, system of collective fact-checking. It's how science filters out mistakes and wishful thinking from genuine advances. Brown's work never passed this critical test. Throughout the decades, countless independent physicists and engineers in universities and private labs, intrigued by the lingering stories of Brown's work, decided to investigate the effect for themselves. They built their own lifters. They replicated his experiments, and with near unanimity, they arrived at the same conclusion. The effect was undeniably real, and it was undeniably caused by ionic wind. Study after study was published in respected journals like the American Journal of Physics and the Journal of Electrostatics, all confirming the EHD explanation. They carefully measured the thrust under different atmospheric pressures and with different gases, showing that the force was directly dependent on the properties of the surrounding fluid. And of course, they performed the crucial vacuum chamber tests time and time again, always with the same result: no air, no force. Even today, organizations dedicated to exploring the frontiers of physics, like NASA's EagleWorks Propulsion Research Laboratory, a group famous for seriously investigating concepts like warp drives, have examined these claims. They, too, have concluded that the forces observed in these devices are entirely consistent with the predictions of ionic wind and provide no evidence for any new gravitational physics. The numbers themselves tell the most compelling story. As we touched on before, the critical metric for any propulsion system is its thrust-to-power ratio, how much push you get for your electrical buck. For ionic wind thrusters, this value is consistently low, typically in the range of 2 to 5 newtons per kilowatt of power. A newton is a unit of force, roughly the weight of a small apple. A kilowatt is a unit of power. A standard hairdryer uses about 1.5 kilowatts. So, for the energy needed to run a hairdryer, you get a push equivalent to the weight of a few apples. Every credible experiment on Biefeld-Brown-type devices has produced results squarely in this range. There has never been any unexplained, anomalous excess thrust and would hint at a deeper, more exotic physical principle at play. This process of communal skepticism, independent replication, and painstaking measurement is not a personal attack on an inventor or a conspiracy to crush a beautiful dream. It is the very essence of the scientific method. It is a system of organized, constructive doubt designed to protect us from our own biases. It is how we, as a species, collectively separate what is demonstrably true from what we simply wish to be true. Thomas Townsend Brown was a brilliant, passionate, and imaginative man. He saw a wondrous effect, and he dreamed a magnificent dream of what it could mean. But the slow, careful, collective work of the global scientific community provided a different, more grounded explanation. They honored his initial observation by studying it with the seriousness it deserved. And in doing so, they found its proper place within our understanding of the universe, not as a revolution that toppled Einstein, but as an early and important exploration of the fascinating and still promising field of electrokinetics. And so our story, which began with a tantalizing promise of anti-gravity and silent, otherworldly flying machines, now arrives in the quiet, methodical laboratories of the present day. And it might be easy to think that because Brown's grand theory of gravity was incorrect, his life's work was ultimately a failure, a curious but dead-end detour in the history of science. But that perspective misses the true and perhaps more beautiful legacy of his work. His legacy is not one of failure, but of serendipity. He may have been charting a course for a distant, mythical island, but in the process, he drew an exquisitely detailed map of a different, very real, and very valuable territory. The field that Brown helped to pioneer, electrohydrodynamics, EHD, is thriving today. Modern researchers, fully aware of the physics of ionic wind, are not chasing the ghost of anti-gravity. Instead, they are deliberately and ingeniously harnessing this silent, solid-state force to create a new generation of technology that is remarkable in its own right. Perhaps the most breathtaking modern example of this legacy unfolded in 2018 at the Massachusetts Institute of Technology, or MIT. A team of engineers and scientists, led by Professor Stephen Barrett, achieved a feat that would have surely brought a tear to T. Townsend Brown's eye. After years of painstaking work, they successfully flew the world's first ever airplane with no moving parts in its propulsion system. This wasn't a flimsy balsa wood model hovering on tethers. This was a true self-propelled aircraft, a sleek and elegant glider with a wingspan of 5 meters, about 16 feet, and a weight of about 5 pounds. Let yourself picture this for a moment. Imagine a vast, quiet indoor gymnasium. A slender, futuristic aircraft is launched into the air. But there is no roar of a miniature jet engine, no furious buzzing of propellers. There is only a deep, profound silence, punctuated by a faint, almost imperceptible hiss. The plane, officially named version 2 of the Ionocraft, glides through the air, stable and sustained, powered entirely by the gentle, persistent push of ionic wind. Its design was a direct, sophisticated descendant of Brown's early capacitors. Stretched along the leading edge of the wings were a series of very thin wires, the positive electrodes. At the trailing edge of the wings were thicker, airfoil-shaped sections, the negative electrodes. A custom-designed, extremely lightweight power supply unit on board the plane created a massive 40,000-volt electrical potential between them. This powerful field ionized the air around the thin wires at the front, creating a cloud of positive ions. These ions were then powerfully accelerated toward the negative airfoils at the back, dragging a river of neutral air molecules with them. This constant, silent jet of air flowing over the wings generated the thrust that propelled the aircraft forward. It was a monumental achievement in engineering, a Wright brothers moment for solid-state flight. The MIT team was explicitly clear about the physics involved. They were not tapping into any unknown forces or manipulating gravity. They were masters of electrohydrodynamics. Their success came not from a new theory, but from decades of incremental advances in other fields, in materials science, which allowed them to build an incredibly strong yet lightweight airframe, in power electronics, which enabled them to create a high-voltage power supply that weighed only a few hundred grams, and in computational fluid dynamics, which let them precisely model and optimize the flow of the ionic wind. The potential applications for this silent, reliable form of propulsion are vast and exciting. Imagine small reconnaissance drones that can fly with near total silence, perfect for sensitive military operations or for observing wildlife without causing distress. The lack of moving parts, no gears to grind, no bearings to wear out, no blades to break, means such craft could be exceptionally reliable and require minimal maintenance. But the applications of EHD extend far beyond aircraft. In fact, you might already have a device in your home that uses this very principle. Many modern, high-end air purifiers operate as ionic wind machines. They use sharp needles to ionize the air, causing airborne particles like dust, pollen, and smoke to become electrically charged. These charged particles are then attracted to and collected on oppositely charged plates, effectively scrubbing the air clean, all without the constant hum and energy consumption of a mechanical fan. Another burgeoning field is the cooling of electronics. Every single computer chip in your phone, your laptop, and in the massive data centers that power the internet generates a tremendous amount of waste heat. This heat is the enemy of performance and longevity, and it is usually removed by small, noisy, and failure-prone fans. Researchers are now developing EHD coolers, or ionic wind pumps, that can be built directly onto a microchip. These tiny, solid-state devices create a constant, silent flow of air over the chip's surface, cooling it far more efficiently and reliably than a traditional fan ever could. Imagine a future of powerful gaming computers and vast server farms that are completely silent. And even the dream of using this technology for exploring other worlds has been reborn in a more realistic form. While ionic wind is useless in the hard vacuum of interstellar space, it could be perfectly suited for flight on other planets with thin atmospheres. Mars is a prime example. The Martian atmosphere is less than 1% as dense as Earth's. Conventional helicopters, like the one on the Perseverance rover, have to spin their blades at incredibly high speeds to get any lift. A winged aircraft with propellers would be wildly inefficient. But an ionic wind-powered aircraft, specifically designed for a low-density fluid, could potentially soar through the thin Martian air for long periods, exploring canyons and volcanoes in a way no ground-based rover ever could. This modern research is a truly global endeavor, highlighting the collaborative nature of science. While our story focused on American pioneers, brilliant minds from around the world are pushing the boundaries of EHD. Scientists like Dr. Kidabuing So, Choi in the United Kingdom have made significant contributions to understanding the fluid dynamics of ionic wind for reducing aerodynamic drag on vehicles. In Japan, researchers are exploring its use in precision manufacturing processes. The work of scientists like Dr. A.P. Yoganandini in India on EHD micropumps for medical, lab-on-a-chip devices showcases the incredible versatility of this force. Science is not the work of lone geniuses, but of a global community sharing and building upon each other's discoveries. So, what is the final, enduring legacy of Thomas Townsend Brown? He was a dreamer. He was a visionary. And on his central, most cherished claim, he was mistaken. He was not the discoverer of anti-gravity, but history should remember him as a pioneer of electrokinetics. He was one of the very first people to build and seriously study devices that used pure electric fields to command the air. His life's work, born from a magnificent but incorrect intuition about gravity, accidentally laid the foundation for a whole new and vibrant field of engineering. His story is a perfect, soothing reminder of how scientific progress truly works. It is rarely a straight, triumphant march from question to answer. More often, it is a long, winding, unpredictable path. Sometimes we set out in search of a dragon, and though we never find one, we return with the cure for a disease. The value lies not just in reaching the intended destination, but in the discoveries made along the journey. T. Townsend Brown spent his life chasing the ghost of electrogravity. But in that noble and persistent chase, he showed us how to command the wind with nothing more than silence and electricity. And that, in its own quiet, elegant, and profoundly useful way, is a kind of magic after all. So as you drift now, deeper and deeper into a peaceful sleep, perhaps you can imagine that silent flight. No roaring engines, no spinning blades. Just the gentle, steady push of a wind born from an invisible fire. A quiet hum carrying us softly into the future.